Hi, welcome to the video lecture series of Fluid Mechanics Laboratory. Today, we will be visualizing 2D laminar flow over different models, and we will be determining the velocity based on the equations of the potential flow. Here, water flows in a very thin channel. So, this type of flow is called as the heel shaft flow. Heel shaft flow is a flow in a shallow geometry. A shallow geometry means the height of the channel divided by the width of the channel should be less than 1. The flow is laminar and steady. We have learnt in our theory classes that in case of steady flows, the streamlines, the streak lines and the path lines are identical. So, here if we are putting a dye in the stream of water, then technically we will be seeing the streamlines, and we can apply the concepts of streamlines and the equations of streamlines to determine the velocity. Now, let us see the experimental setup. We have got two tanks here, and the flow is controlled using this valve. The flow rate is measured using a device called as the rotameter, and the unit is in liters per hour. This consists of two glass plates, and the bottom glass plate is fixed with a paper which has grids. The gap between these two plates is 2 mm, and the water steadily flows inside the channel. These are the three models which we will be placing inside, and we will be observing the streamlines over these models, and the thickness of these models is also 2 mm. Now, I am placing the circular model. This is the dye, and this dye is povidone iodine solution, and this dye will be injected in the water stream using these ports. You can observe the streamlines over the cylinder. From the theory, we know that the difference between the streamlines is equal to the flow rate. From the rotameter, we know that the flow rate is 600 liters per hour. We know that the flow rate is equal to the area into the velocity. So, we have to determine the u velocity, that is the velocity in the x direction. So, I know the difference between the streamlines, that is equal to flow rate, and the delta y, I have to use this scale to know the delta y. That using this I can determine the x velocity. Similarly, now I will keep the next model, which is the aerofoil. Here you can observe in the aerofoil, the bottom, in the bottom these two streamlines, from these two streamlines we can determine what is the velocity. The delta y at the bottom is more than the delta y on the top. So, here the pressure on the top will be low, that is delta y is small, represents that the velocity is more, and the pressure on the top is low. And similarly, on the bottom side, the delta y is more, so the pressure will be higher. So, on the top we will have low pressure, which makes the aerofoil to lift. we can observe the streamlines for the square section. Now we have visualized the streamlines for square, aerofoil and cylinder. Next we will see how to calculate the x velocity.